Dual in the sense what? All the zeros will be converted to 1 and all the 1 will be converted to 0. If I multiply any number with its complement, then it will be equal to 0. We have to state and prove. For that statement, we are going to get 1 marks, and you have to write a truth table that will be for another 1 mark. So in the place of x and x, no need to do anything. I just wanted to change the plus to product and 0 to 1. Hello everybody, a warm welcome to one and all. Welcome back to the revision class and chapter 2, that is Boolean Algebra. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. So we'll see the marks distribution of this chapter. So from this chapter, you are going to get 2 questions, that is in the part A, that is 1 mark. So totally you are going to get 2 marks in part A, and in the part B, that is 2 mark question, you are going to get 1 question that is for 2 marks. No need to worry about the 3 mark question, and you are going to get 1 question from 5 marks, that is part D. So total it will be for 5 marks. So from this chapter you are going to get total 4 questions and it will be for 9 marks. We'll see the 1 mark question from this chapter. What is the first question? Give the other name for Boolean Algebra. So what do you mean by Boolean Algebra? And they are asking you the synonym for this Boolean Algebra. So Boolean Algebra is also considered as what? Switching Algebra. What is the alternative name for Boolean Algebra? That is switching algebra. So what is the second question? Define truth valued variable. So as we all know that, so if I say variable from this Boolean Algebra chapter, it will just going to deal with only zeros and ones. So if it is a 0, that is false. If it is 1, that is related to true. So we'll see now. So the truth values are depicted by logical constants, true or false. So these truth values have only true or false. So if a variable is capable, or the variables which can store these truth values are called as truth valued variable or binary valued variable. So here also we have alternative, truth valued variable or binary valued variable. Binary in the sense what? It will going to deal with only twos, that is what? Zeros and ones. If it is 0, that will be false. If it is 1, that will be true. So if a variable is holding the value or which can store these truth values called true and false will be considered as what? Truth valued variable. We'll see the next question, that is, what is truth table? What do you mean by this truth table? So a truth table is a mathematical table used to represent a Boolean expression of a logic gate function. So we are going to use one mathematical table in order to represent the Boolean expression of this logical function. That may be logical function can be related to and or not. Okay, so in order to represent all those function of a Boolean algebra with a mathematical table representation, that will be considered as what? Truth table. Next question, what is canonical expression? What do you mean by canonical expression? So Boolean expression expressed as sum of mean terms or product of max terms, that will be considered as canonical form. So the Boolean expression will going to be expressed as sum of mean terms and product of max term. Then that will be called as canonical forms. What is the next question? Write the dual of 1 plus x. Very, very important question. So dual in the sense what? All the zeros will be converted to 1 and all the 1 will be converted to 0. And plus will be converted to product and product will be converted to plus. So what is the question we have here? 1 plus x. So you should not bother about x, y, a, b, c, d. Okay, you should not worry about the variables. Main thing is about what? Only plus and dot product, only about zeros and ones. So you need to concentrate on those things. 1 plus x. Then how I am going to find the dual? What is the alternative of this one? What is the dual of 1? That is 0. In the place of plus, what I am supposed to do? That is product. So x will be as it is. So the answer will be 0 dot x. That is what we are going to get as a dual of this 1 plus x. So now we'll see the 2 marks question from here. So as we all know that we have to concentrate on all the laws from this chapter that can be either asked for the 1 mark question or can be asked for 2 marks question. That means what do you mean by or define involution law, define commutative law. So those kind of questions are also important for 1 mark question. So define absorption law. So you need to learn its definition of all the laws. So I have one more slide in this session. I will show you how you are supposed to write the answer and how you are supposed to remember. So we'll see the first question related to this 2 mark question, that is prove that x plus xy is equal to x. So if I say this question, you have to understand this belongs to which law. So x plus xy is equal to x, it is of the absorption law. Then what is this absorption law states that? So here they are not asking you to write the definition. For your convenience, I am just writing the statement of this absorption law. What this absorption law states that? So this law enables a reduction of complicated expression to a simpler one by absorbing common terms. So we are just making an expression as simple as possible. That means we are reducing its complexity by finding the common factors here. So we'll see the question, x plus xy is equal to x. So that means I need to prove x plus xy is equal to x. How we are going to do that? Let me consider the LHS, that is x plus xy. Okay, so if you observe this, what are the common things that I have in both of the part here, x plus xy? So I just have a common of x. So let me consider this x and let me take the common factor will be 1 plus y. So x into 1 plus y. Already we have learned 1 plus y. So if I add any number with 1, then that will going to give me 1. So 1 plus any number will going to give you 1. So that instead of writing this 1 plus y, I just write this as 1. So that is what x into y. Let me write that as product x dot 1. If I multiply any number with 1, then I am going to get 1 only. So x into x will be x here. So we have got the RHS. That is what the absorption law will going to states. We'll see the next question. Write the properties of 0 and 1. So we have to understand all the basic laws or basic postulates from this Boolean algebra. So 0 plus x is equal to what? X. So if I add any number with 0, then I am going to get that number. It can be either 0 or 1. So 0 plus 1 will be 1. 0 plus 0 will be 0. So that 0 plus x will be x. Then 1 plus x is equal to 1. So if I add any number with 1, then it will be 1. So this x can be either 0 or 1. So 1 plus 0 will be 1. Even 1 plus 1 is also be 1. So that 1 plus x is 1. Then 0 into x is equal to 0. So if I multiply any number with 0, then it will be 0. Okay, then 1 into x is equal to x. So that means what? Whatever the variable, that is 0 or 1 only. So if I multiply anything with 1, then I am going to get that variable. For example, 1 into 0. So here x is 0. Here 1 into 0 will be 0. That is x is equal to 0 itself. That is what? 1 dot x is equal to x. So remember all this x1, 0x. Okay. So 0 plus x is equal to x. 1 plus x is equal to 1. 0 into x is equal to 0. 1 into x is equal to x. And we have to understand one thing. So if my x value is not equal to 0, then it's supposed to be is equal to 1. So if x value is not equal to 1, then it must be equal to 0. So these are the properties of 0 and 1. We'll see the next question. Prove that x into x plus y that must be equal to x, which is also related again with this absorption law. So let me consider the LHS here. So LHS is equal to what? This x into x plus y. So let me multiply x into x will be x dot x plus x into y, that is xy. Okay. So already we know that x into x will be equal to x only. That means if I multiply any number with the same number, we are going to get the same value. For example, 0 into 0 will be 0 and 1 into 1 will be 1. So that is what. So in the place of x dot x, I am just going to write x. Then plus xy will be as it is. Then I am going to take a common of this factor x of 1 plus y. So x of x is common here. So it will be 1 plus y. Already we know this. So if I add any number with 1, then it will be 1. So that in the place of 1 plus y, I am going to take that value as 1. So x dot, so this is multiplication, x dot 1. So if I multiply any variable with 1, then we are going to get that variable. So it will be x. So that we have proved LHS is equal to RHS. That is what we have proved this theorem. This is related to question number 3. We'll see the next question. Prove algebraically that x plus y into x plus y bar is equal to x. So we have to prove that. Let me take the LHS here, that is x plus y into x plus y bar. Let me multiply this. X will be multiplied with xx, then it will be plus x y bar, plus y will be multiplied with x, then it will be xy plus y bar. Then, so as we all know that x dot x will be x only. So in the place of x dot x, we are going to write x plus y bar will be as it is, xy will be as it is. Then if I multiply any number with its complement, then it will be equal to 0. So then I am going to write it as 0. Then I am going to take the common factor as x. So x plus 1 plus y bar plus y here. So that as we all know that we are going to take y plus y. So that is equal to 1 only. So then x dot 1 will be going to give us Ax. So we have proved that LHS is equal to RHS. This is how we are going to solve this from Boolean algebra expression. We'll see the next question. State and prove commutative law using truth table. So we are going to get these kind of question for 2 marks. So if they are just asking you to define the commutative law, then it will be for 1 marks. So we have to state and prove. For that statement, we are going to get 1 marks. And you have to write a truth table, that will be for another 1 marks. Then what commutative law states? This law states that the order in which the two variables are odd or ANDed make no difference. Whether it is x plus y is equal to y plus x or x dot y is equal to y dot x, that doesn't make any difference. That is what we have to prove with a truth table. So we'll see the x plus y is equal to y plus x. So in this, how we are supposed to solve? Consider the y value as 0 here. After that, x plus y, LHS is x plus y. In the place of y, take 0, x plus 0. So if I add any number with 0, then it will be that variable. That is what we got, x. Then y plus x, that means you take this RHS. In the place of y, replace 0, then plus x. So if I add any number with 0, then it will be that variable. That we have proved that LHS is equal to RHS. So same thing will going to be applied for when y is equal to 1. So here we have a truth table. So that is what you can see that both x plus y and y plus x are same value. The resultant will be same here. In the same way, we are going to do it for product. That is when we are ANDed with the variable. That is x dot y is equal to y dot x. Along with its truth table, you have to write. Here also you can see that x dot y and y dot x both will going to yield the same result or output. That means we can say that this commutative law has been proved. We'll see the next question, that is state and prove complementary law. In the same way, you have to write its definition. Then after that, you have to write its, what do you mean by complementary law? Along with that, you have to write that variable's expression, then with a truth table. So this law states that when a variable is ANDed with its complement, it's equal to 0. And a variable which is odd with its complement, then that is equal to 1. So that means what? When I complement or when I ANDed this variable with its complement, then it will be 0. So when I odd variable with its complement, then it will be 1. This is what we are going to learn in the complementarity law. So we'll see this. X plus x bar is equal to 1. Consider x value as 0 here. Consider the LHS x plus x bar. So 0 is the x value. X is 0, then x bar must be 1. So 0 plus 1. What we are going to get? 1. So that means we have proved this one. X plus x bar is equal to 1. So LHS is equal to RHS. In the same way, here also I can take that. If I wanted to do the product, x dot x bar is equal to 0. So you can see here x value is 0 here, then x bar must be 1. So 0 into x bar is 1. So 0 into 1. If I multiply any number with 0, then it will be 0. So that we have proved LHS is equal to RHS. Then don't forget to write this truth table. So if I add any number with 0 and any other value, it will be 1. So if I make this x value as 1, the complementary will be 0. 1 plus 0 will be 1. So here, if I product it or ANDed it, then it will be 0. We'll see the next question. That is, what is min term and what is max term? Very, very important question for 2 marks here. What do you mean by min term? So you have to write its definition. So min term is a product of all the literals. Literals in the sense constant. It's a product of all the literals that with or without bar within the logic system. Write these 2 lines in order to get 2 marks. Very, very important question from this chapter. What is min term and what is max term? So this is most frequently asked question. Min term is a product. So minimum in the sense what? You don't take or you should not compare with a addition. So minimum in the sense you have to take that as a product. You just imagine you are getting the product for minimum cost. So what it means then? It is a product of all the literals. So it can be either with bar or without bar within the logic system. So then what could be the max term? Then it will be, if min term is a product, then max term must be sum of. Okay. So that is max term. It is the sum of all the literal, even that is with or without bar within the logic system. So here I have one more definition for this min term and max term. So instead of that, you can go with this. Min term is what? Product of all the literals with or without bar within the logic system. And max term is what? Sum of all the literals even with or without bar within the logic system. This is what you have to understand and you have to write for this question. We'll see the next question. Write the applications of De Morgan's theorem. So anyway, we know that this completely De Morgan's theorem concept is very, very important question from this chapter. So here they are asking you to write its application. Where and all can we use this De Morgan's theorem? So it is used in simplification of Boolean expression. That is what we are all using in the Boolean expression in order to simplify. So then De Morgan's law commonly applied to text searching using Boolean operators called and, or, and not. So it will be used in text searching using Boolean algebra called and, or, and not. We are just going to make a comparison and we are going to use this in a text searching. Then it is useful in the implementation of the basic gates operation with alternative gates. So basic gates are and, or, and not. So using those gates, we are going to have some other alternative gates called derived gates or universal gates. So these are the application and it is very, very important question with respect to 2 marks. We'll see the next question. What is principle of duality? Give an example. So understand one thing. Principle of duality will be for 1 mark and if you are giving an example will be for another 1 marks. What is principle of duality here? So this principle of duality states that changing each or sign, that is plus to and sign product, and changing each and sign dot to or sign plus. So it's too easy in order to remember. We are making a changes with plus will be replaced by product and product will be replaced by plus. 0 will be replaced by 1, 1 will be replaced by 0. That is replacing each 0 by 1 and each 1 by 0. So this is what principle of duality will going to state. What are the example? Here I have mentioned some of the example. This is the original, that is Boolean expression. That is what duals of this one. So x plus 0 is equal to x. So in the place of x and x, no need to do anything. I just wanted to change the plus to product and 0 to 1. So here x will be as it is. In the place of plus, I am just wanted to write product. In the place of 0, it will be 1. So that is x dot 1 is equal to x. So these many examples that I have given here, out of this you can write any one in order to get 1 mark with respect to example. We'll see the next question. What is tautology and fallacy? It is most frequently asked question in the 2 marks. We'll see what you mean by tautology here. So if results of any logical statement or expression is always true or 1, then it will be considered as tautology. In the same way, if the results of any logical statements or expression is always false or 0, then that will be considered as fallacy. It is very important question and somehow it is easy to learn this question, that is tautology and fallacy. So here you can see the important tabular form from this chapter. That is what here I have listed out all the theorems along with its Boolean expression. So totally we have 21 expression. All these will going to be important for 1 mark, 2 mark as well as for 5 mark questions. So how can I state that? So the question will be like, write the properties of 0 and 1. Already we have learned regarding that. And what do you mean by idempotence law can be asked for, that statement can be asked for 1 marks, or they can ask you to prove this for 2 marks questions. And also we have a complementary law. So whatever I have mentioned as the law here, your main thing is what? You have to understand its definition and you have to learn which are the Boolean expressions which comes under which law. Along with that, you have to understand how to solve or how to get a proof for this. So take a LHS and prove the RHS. So all these 21 theorems, 21 laws are very, very important question from this chapter. So if you study this, you can easily score 5 marks, 2 marks as well as 1 marks. Write all the definition, learn all the definition of each law here and learn what are the theorems which comes under this particular law. This is important tabular column that I have made in order to make you the chapter called Boolean Algebra to be easy. We'll see the 5 marks question. So when it comes to the 5 marks question, without worrying anything, you have to learn K-map, how to solve or how to reduce the Boolean expression using K-map. Very, very important question. So surely you are going to get either K-map or De Morgan's theorem in the 5 mark question. There is no alternatives or there is no other possibility of asking a question, or else they may ask you the question like they are going to give you the 5 laws, right? Define commutative law, define absorption law. So that kind of question you may get. So apart from that, surely you are going to get one Boolean algebra, that is one reduction of a Boolean expression using K-map, or which will be related to De Morgan's theorem. Only those 2 possibilities are there when it comes to the 5 mark question. So we have listed out some of the most frequently asked K-map question. Along with that, mainly what we have here, state and prove De Morgan's theorem using truth table. So when it comes to the De Morgan's theorem, you have to solve both De Morgan's first theorem as well as De Morgan's second theorem. It will be very, very important question, and learn and should not skip this K-map. Somehow it is very easy. Don't consider this as a complicated task. Go with the K-map, learn and reduce this Boolean expression using K-map in order to get 5 marks. So these are the only important questions that you can expect from this chapter. It's all about today's session. I hope you all understood. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.